face. Okay, on cereals, on rice, on experiment. Getting my point? Then you have to run the model over there by selection of all the experiments. Because these are inbuilt experiments, so they don't have any problem in running right now. But when you will create your own files, might be there are some deficiencies. That's why they take time, model takes time. So when you will go to the analysis, so you have to go for the, you can say, plant out, plant grow out. You can say if you are if you have to go for evaluation, then there will be, you can say, view, sorry, plot, and site type of analysis will be there. See, this is the same that we have already mentioned, I think. So these are the, you can say, it's a course. Almost it's 9:30, 9:40. Okay. Okay. So this is about the values. Keep in mind. So if you want to collect the values and make the graph by yourself, then this is the you have to go in evaluate out, right? For graph, or you can say graphical representation, then you have to go back and go to the plant grow out, mean graphical representation over here. Okay, so over here you will see the values in graphical representation. That was in figure, or you can say in digital comparison. But now, according to your simulated and according to your observed, that I see you in yesterday's slides in graphics. So this is going to be graphic representation of that type of particular parameters for different types. Mainly, we consider four parameters that I already told you: NCS date, tops weight, grain weight, being agronomist, honestly, and harvest index. Harvest index. Do you know harvest index? Good. So normally we take these parameters and with full consideration because by selecting these parameters, you can see the difference between your yield, crops, and also regarding your leaf area index time scale parameters with different treatments. Say for example, now we are going to select, say for example, the maximum one. Okay, the maximum. So this is basically the graph that's showing the difference between your input data and the output data. If you go, you can, for further clarification, you can deselect some of the parameters. Say for example, you can unselect this, unselect this. You have to go for leaf, not leaf number, leaf area index, tops weight, grain weight. Where is grain weight? unit grain weight. Okay, this one. This is yield basically. This is unit grain weight. This one, individual grain. And I think we don't have to count this one. So we have to count yield, leaf area index, and tops weight, mean total dry matter in kg per hectare. So again, you have, if you go to this one, then this is the true picture. So, for example, with time scale, the lines, complete lines shows the simulated or model predicted values, not values, the curve. Okay, while the dots shows the observed data that you have. Okay, understand? No response.
Yes, sir.
Good, good. Who is there? You have, you have, you don't need to select all. Okay, run all, run model. Good. Go to analysis, the top one. Then grow. No, 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 no. Next one. Yes, this one. Exactly. The same one that you are putting. Then go to plot. Close this one. Minimize this one. Yes, you are here. If index drops and wait. The highlighted one. Yes, exactly. Good. Put and select the treatments on the right side. Not all, but maximum. Maximum. 5 1, 5, 10, and 15. Only 5, 10, and 15. The maximum.
Is it লেখা আছে নিচে?
Yes, no tax. Is it? Understand? Good. Good. Okay. Sorry for your background. So you can also play from your mouse keys as well. Don't worry. Good. Yes. Each individual treatment has individual results. It depends. But right now we have selected only the maximum nitrogen comparison between the observed and the simulated one. So don't select all of the treatments, only the maximum one. Okay, got it? Good, good. So this is all about, say for example, the red line shows, the first one shows that this is the simulated value, simulated line that is predicted by the model. While these dots are the observed value or experiment value that you have put it in. So mean your experiment with respect to leaf area index with respect to time, right from 0 till 178 days. It's perfectly going accordingly. So each of the management factor that you have done with your experiment is perfectly fine. If you are going towards the next is the dry weight, or you can say tops, or you can say total dry matter. That again, that is almost how to say this is
Maroon.
maroon. Exactly. Maroon. Thank you. Maroon. This is maroon line shows basically the total dry matter. Line is the simulated one, while the dots for maroon line mean whereas the observed value. Uh, sorry. No. Yes. Crosses. These are the crosses of total dry matter. Maroon crosses. Keep in mind. Maroon crosses mean over here the model shows that your top's weight should be, I mean, around 5,000. 5,000 kg per hectare at the day of around, you can say 50 days. While observed is around 4,000. So there is difference of 1,000 kg per hectare in your top's weight regarding your crop difference. That might be due to, again, due to soil, due to nutrition. Keep in mind, NPK is the not the complete solution of, you can say, of all the nutrients. It should be the equal nutrition from micro and macronutrients. So that might be the reason, or even there is, you can say, increase in temperature during these days. This is rice, right? Am I right? Yes. Rice. So after, after 50 to 70 days, 50 to 70 almost, there might be increase in temperature as well. Got my point? There is any other, you can say, issue that the model is simulating higher yield, or you can say higher, sorry, crops weight, the dry matter instead of your observed value of the tops weight. While with the passage of time at 80 days, I mean you have skipped the irrigation might be there. While at the 80 days you are at par with with that one, and at almost 97 and up to 105 6 days you are at par with, exactly at par with the simulated value. So it's you can say excellent value. You can say the observed and the simulated values are the same at the end. But with the with respect to the time scale, it should be just like this one. Okay. So how you get these values? Who will tell me the observed value of these tops weight according to time scale prediction? Yes. But how you will put it in the model? I mean, on which basis? Exactly. By putting the you can say collection or collecting the data with respect to time scale. Say for example, you take the data after 30 days and descriptive sampling. Okay. In Cox weight by descriptive sampling, you can make it in accordingly according to every 30 days. 30 days, almost 50 days, 65 days, 80 days, 15 days. It might be, it's not only, you can might be up to 15 days, might be 20 days. But again, as there will be the complete, you can say, how to say, there is a uniformity actually in the days, the accuracy will be there. Say for example, if you have to collect the data after every 20 days, then it will have more accuracy according to the model prediction. Got my point? Yes. Mean
Sir, I have a
after 20
question.
days? Yes. After 40 days you have to take the data. Mean it doesn't mean after first data you have to take at 30 days, then next data you have to take at 80 days. So there will be problem within the time scale and simulated and observed value. And you are unable to make the comparison. Got my point? So as there will be the maximum observed values, their accuracy between model and your observed values will be maximum. Yeah. Yes. No. 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 For yes, this is only for crop. We are showing you over here time series. Look at on the above. This is time series data for crop only, not for soil. Yes, when you are going to put the soil data, you will have to collect the data of soil by taking the sample before sowing up crop and after harvesting the crop. Twice. Yes, that's one time might be okay. No worries. Then before sampling, before sowing, it's enough. If you are going to sequential analysis, mean crop rotation, cropping system analysis you are going to do, then you have to take the data twice. Mean sometimes there are some data from the soil amendments. Say for example, by sowing your legume crop, what are the impacts of legume after harvesting the crop on the soil nutrition? Then you have to take the data twice. For soil, keep in mind, not for the crop. Okay? So, different soil scientists basically have to have the observation and experiments on basically on the soil amendments, soil nutrition, soil health, and just like the things. Then they have to collect at least twice. You can say even after establishment and within the interval of different stages as well. They have to collect. But we don't have such type of we are not go to the detail. So this is all about you can say simulated and the observed values. So just great. Okay. So this is your you can say tops weight, your LI and grain. So this is your grain yield. Model says that it should have to work after 80 days. And with the increase in you can say with the increase in you can say days, the yield should be at this one, and this is the exactly the same yield that the model is predicting. Mean almost 4,000, 100 kg per hectare, right? Almost around 4,000 kg per hectare. So this is the same one. Accordingly, if you go for the grain yield, this one, and tops grain weight kg per hectare. So what is the difference between you can say who will tell me what is the actually we select two. So actually we have select two treatments, treatment 5 and treatment 10. That's why there are two grain weights. You don't need to be confused. Just go back. Look, treatment 5 and 10 and 15. There are three treatments. That's why there are three. This is the plotted value of three treatments: 5, 10, and 15. For more accuracy, you have to select only one. Then you have to plot. Then this one. you have to more clarification in your observed data and above all the parameters. Please. Any question at this stage? Complete name of your university. So any question up till now? This is only for one treatment. You can play for treatment one, two, three individually or as a comparison. Don't worry. Okay. So keep in mind when you run the model, then they run all the treatments. Don't worry. No need to run again and again. Just you have to go back, okay, and you can deselect this one. You can select any of the next one. Then you have to go with this one. This will change. No need to close this one and the interface and run again, go back again. No, 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 no. Simply you have to select the required treatment. Then you have to go, please check the box, play next. So these are the values. So these statistics, if you want to get the required results in these statistics are statistic way, in numbers way, then you are all the numbers are here. So you can see different time scale data, yield data, the statistics. What is this RMSE? Please.
Root mean square. Root.
Good. And you can export to Excel directly simply by putting over here. All the data will be shifted to Excel. Look, these are the values, exactly the same one that we displayed over there. Main RMSC, say for example, I have to show you again these one. Look, if you go for further RMSC, right? The same values and the chart automatically. No need to select all the data and you have to prepare the graph by yourself. Simply export to the file, it will be automatically go there. Got my point? Any problem? Yes, please. Yes. Yeah. Yes, that is, and you can do in this way. Yes, you don't have to save. Exactly. That I told you, don't save any of the data in examples file. Okay? Being learner, being the initial, you can say, educator of the model, please don't save any file. Yes, you can save the file from your own data by creating. After the break, we will have to start the how to create crop file, I mean experiment file, soil file, and met file. Yes, you can save your own file, but don't save any of the exemplary file within the model. Please. Is it possible though? Sometimes, if yes, it's possible. Then the accuracy, the required results of the exemplary file will be disturbed. For other users as well? No, for only for this business. Because he has saved all the data. So the simulation results within the exemplary file or exemplary, you can say, experiments will be changed. I mean, this is human error, might be human error, it will be there. Then that will definitely have the impact on your own simulation. Got my point? Good. So this is all about regarding graph, and you can also play with the greenhouse gases because you know, as I already told you that there are lot of variation in the model. If you have experiments, say for example, regarding evapotranspiration, you have to go over there. If you have greenhouse gases, some researchers have the research on greenhouse gases, and they have to find over there. If someone have to the information about all the experiment, then they have to click over there. Some of the soil scientists have mulch experiments. Then they have to run this one. Some of the soil scientists have nutritional experiments on the soil. Then they have to go for this one. And same for different types of soil, nitrogen balance, you can say soil temperature, water balance, and so and so. So this is the list of, you can say, different types of experiments. So you can see all the information from the same interface with the same run at the same time. No need to run the model again and again. Once run, then you have to get all the information from these parameters. Please. Please show something about this soil. Yes. So within the existing, you can say experiments, if we go toward the soil balance, what is the status of soil of this specific treatment or you can say experiment, then we have to go for the analysis. Sorry, view. Oh, it's not selected, right? That's why I was saying you have to go to the plot. It's not selected. There is some again you have to refresh it. So run the model again. Over here there might be some refresh over here. Yes, this one. Okay. No need to close the DSAT. Then again you have to run it. Simply refresh over here. So if you go towards this one, run the model, then go to the selection of the specific treatments, run the model. When you will play with the model, then automatically you will be trained. So then you have to go to the analysis, plant growth, or you can say soil balance. No graphical files were selected. Actually, I think because it might be data is not observed data is not provided for specific reasons. That's the question that I asked. That yeah, the model will actually analyze and simulate the yield and the production data. Yeah. Does it also simulate and predict soil related information? Yes. It does? Yes. If you have the data. If you give the data. Yes. If you give the soil relevant data, then I already told you that all the experiments regarding soil, regarding mulch, regarding greenhouse gases, etc., if you put the input data, might be specific soil data for these experiments will not be provided to the model. That's why it's not showing. Might be we can from view. Okay. But we want to have the comparison actually in the graphics form. Might be we can select another file. Yeah. These are exemplified. Keep in mind. So we can play and we can see with the other files as well. So these are the treatments. Say for example, we have to run all the treatments. Okay, we have to go for the analysis. Then we have to go for the soil balance. Okay. Then yes, in view you have to go, but I mean yes, this is but sometimes when you have some data, then it will be shown in view, but it will be manual one, not in the accurately as we see in the experiments one, and that you have to manually convert it into I mean PNG to evaluate, and then a lot of files will be changed. Got my point? So these are different types of you can say soil balance, soil carbon balance actually. Understand? So might be okay. Yes. This one was there. Actually, the model is very sensitive. So this window was already opened. That's why the simulation was not completed properly. So again, you have to open the. Just click one. What we do, we click maximum time. So it, the model itself becomes be confused what I have to do. So that's why you have to click and one time. And sometimes if you don't have space in your PC, then it becomes heavier. Your PC becomes heavier and slow down in running the model. So that's why keep patience. So there are different types of soil. Soil experiments over here, and you are if you have to these are soil file, different types of soil file. You can go over there and you can select different types of soil. So might be we have to again go to the rice. Okay, any of the experiment, run it. Then you have to go for run the model. Okay, so analysis. You have to go for the soil nitrogen, soil water might be. Okay, you can view. Actually, data, I think data is not existed, that's why. But over here in exemplary file, massive majority of the experiments are by the agronomists. So the crops data is, you can say, put it in for the exemplary file. This is the data not from the soil scientist. It will take time actually. Then it will be improved with the passage of time. Might be for greenhouse gases, for mulch, for all types of soil parameters. In later on, might be. In my opinion, the data is not available. That's why it's not running for the soil specific. Okay, but you can try for some experiments. Might be from soil scientists out there. So you can find the soil status of the respective experiments as well. So this is all about from your experiments, how they are going to have such type of things, interfaces. You can run the simulation for different cereals, all types of crops. I don't know. You can go some type of crop that might not have been included over here. Might be. If is it, then chances are there your experiment can be included in the DSAT model. Chances are there. So in case, I mean, in my case, when I start experiments on oil seed, the experiment still was on DOS based, as the initial DSAT model was running. But that was big challenge because if you are proficient in your skills in computer, then you can run only in DOS based because there are different types of languages you have to put it in. But if it is in window based, then it's very simple. But all the experiments that are for different crops over here are almost more than 99% are window based, not the DOS based. So you don't worry about that one. Got my point? Anything else up till now? So this is all about, you can say, overview of different crops, their simulations, their comparison with simulated and the observed one, and so on. So in after the break, we will go for different types of crops, I mean files for the minimum data sets that we have already discussed yesterday. Experiment data or crop data, soil data, and weather data. So we will have the, you can say, uh, hands-on training on those types of files after the break. Please. Do you have experimental data with you, or you might select one for agronomy thesis? Is it possible? Yes. Yes. First, the purpose of this type of training is just to familiarize you people with the model. So I suggest you have to go with the example file first. When you have the skills, expertise on the example file, then you have to apply those examples file on your own data. Okay? If you will go directly to your own data, then might be it will take time because there are a lot of errors in it. There are some, you can say, when you fly in the aeroplane, they ask you to have the safety first yourself, then for others. I mean for kids or for the neighbors. First you have to scale it and you have to train by yourself first with the examples files. Then yes, you can do and you can have all the material, all the things in your hand. You can, multiply it on your own data for any type of crop. Got my point?
Yes, sir.
Okay. Okay. Thank you very much. Any question? Please ask question. Ask question so that I might have the response from your side. Are you with me, or I mean, are you behind the training? Up till now, it's okay. You are running the model. Yes, please. Example file. Yes. What question? Please. Silent, please. Dr. Jatoi, um, students saying that some of the soil files do run. Yes. And she has found out that one. She wants to show if it is okay. Yeah. As I told you, that some of the experiments are by the agronomist. The data that is inputted in the files will be from the agronomy. It depends from experiment to experiment. Some of the experiments might have some soil related treatments as well. So their input data is over there. That's why those treatments are also going to run. Okay.
It's a soil
So
temperature
it
file is
doesn't
running.
mean so
Soil temperature.
I will show you after the break how to prepare soil data, how to prepare soil file, experimental file, and also weather file. The question from one of the colleague. What was the question?
Yes.
Input file. So all the experiment. The question is all the exemplary file are complete.
Sir, here we are using it as input file or
So these are the interaction of the exemplary file are the interaction of style file, weather file, and experiment file. Complete. While as a beginner from your side, we have to prepare style file individually. Weather file or experiment, weather file as well as crop or experimental file individually. That will make the bunch of all three files and then it will be displayed over here. Got my point? Exemplary file are the bunch, already bunch of all these types of files. Got my point? Okay. So we have the break over here. Then after the break we will come back with the creation or you can say learning of the different files. Okay? Thank you. Yes, break. How much time do we have to take today? 10 minutes? 15 minutes. Okay.